Hello everyone. Today I'm gonna talk more about the mathematical waves. And the last time, we talked about two different type of graphs. So for example, let me talk more about it. So in general, you have a amplitude y, and then you have a position graph, and then you also have an amplitude y as a function of a time, right? And then we talked about last time, right? The distance between these two positions in y versus position graph is called lambda. And then if you have another graph here, and then the distance between two time period in a yt graph is called period t, right? So then now last time in the last chapter we described the position y as a function of a cosine function, right? We have a 2 pi over t times a time, right? So this is a spring motion, circular motion, and pendulum motion. You can describe any motion using this formula. And then I'm going to compare this formula with another formula using lambda. So that is basically y equal a times cosine. Everything same except what? Lambda will replace period t. So it's going to be 2 pi over lambda. Now instead of a t, we have a position. Right? So this is the function for what? Snapshot. Snapshot graph. And this is what? History graph, right? So then now, again, we have another part, right? Amplitude A is always from here to here, right? And then this is a new function for snapshots, right? So we have again lambda over 2 pi instead of a t times x instead of a time, right? And again, this is the picture I just draw, right? Because if it's a y versus a t graph, and then you have a period t, and then the function is given by this formula here. So then now you can combine these two like this way, right? So this is nothing but, if I rewrite it, y function over x and t is a cosine. If you expand here, this is again 2 pi over lambda times x, that's the first one, minus 2 pi over large t times t, right? So especially you gotta determine the sign based on direction of the motion of the wave, right? So when the object is moving to the right, the wave is moving to the right, so minus right plus left. Okay, so this is your final function. Okay, so again, we have two variables, which is x and t, right? So in general, in order to have this function, you basically need three variables, right? What is that? A, lambda, and the period t, and then basically direction of it. So if you know these four information, you can fully describe the wave function, right? So then it depends on x and then t, right? So if you fix x, then your function is a function of time, then it's a history graph. If you fix a time, right, then now it's a function, this whole, term is a coefficient, right, constant. So this is a function of x, then it's gonna be now snapshot at fixed time t, right? So then if the wave is again traveling to the left, we will have a minus sign. If it's a positive, to the right, right? So the period of this wave, what is that? The period of wave. So again, don't make this mistake because you see the distance between two crests here is what? Basically 2 meters. It's not 2 seconds. So this is not your time period t, but this is your wavelength. Okay, but your wavelength and your wave velocity, is what? Distance you travel, from here to here, and then how long did it take? Period of time t. So they assume, the velocity of this wave is 1, lambda is 2, so your t gotta be 2 seconds as well. So your answer is B, but not because this length is 2, okay, but because of this length and speed combination give you period 2 seconds. And then what is the amplitude? Amplitude definition is straightforward, right? Not from here to here, but from the midpoint to one position. So your amplitude here is SP. And then what is the wavelength here? And then whenever you are looking for wavelength or period, right? You have to see what? The x-axis. Again, this time this is a distance. So the wavelength is the distance from here to here. So the answer is 2 meters. Now, a ball is moving to the right with a 5 meters per second with respect to the water. And then the ocean wave is moving to the left. This is your first hint. And then opposite the motion of the boat. The wave will have a 2 meters between the top of the crest and bottom of the trough. So then what is your A? Your A is 1 meter, not 2 meter. And then the period of the wave is given. So this is your T. And then the wavelength is given as well. Right? So then you know A, you know T, you know lambda, right? So basically you can find, and the direction of the motion, right? You can find your wave function, which is a function of x and t is what? A times the cosine 2 pi over lambda x, and then the sign is a plus because the wave is moving to the right, and then 2 pi over t times small t. But we know period is 8.3 seconds, so now we can say this is 8.3 seconds. And then the wavelength is 110, so now this is 110, right? So this is your full wave function, right? Which gives you the height of the boat, basically, right? But now we have to, in order to find so at one instant, the boat sits on the crest of the wave, right? It sits on the crest of the wave, assuming it starts from here. And then 20 seconds later, what does that mean? Small t is 20 seconds, right? So your small t is now 20 seconds. So the only variable you want to find is x, right? But you can find the x as well, right? So initially boat was 5 meters per second, and then travel for 20 seconds. So its position is gotta be 100 meters, right? Which is 5 times 20. So your x is 100. So then now everything's number. Oh, except to the A. What is amplitude? Amplitude is 1. So if you calculate this number, that's gonna be your vertical displacement of the boat, which is here minus 0.42 meters. You see all the same, we have all variables here. 1, right? This is x, this is lambda, this is time t, this is period t, right? And again, as I said, the wave velocity is given by wavelength divided by time period. Or you can say lambda times a frequency, because 1 over t is a frequency. What is the frequency this time? Again, you have an equation, velocity equals what? Velocity is what? Distance you travel from here to here, which is a lambda. And then the time take up from here to here. That's a definition of a period. Or you can also say this is a lambda f as well, right? So that says velocity is 200. So that means 200 equals lambda times the frequency. But what is the lambda? Distance from here to here is 2 meter. And then your frequency. So your f is 200 divided by 2 is 100 hertz. So the answer is B. And then we have two different type of graph. One history graph. So that is the function of time, right? And then this is a snapshot graph. And this is a history graph, because this is a function of time, right? So then now, what is the speed? Again, speed of the wave is given by distance travel divided by period, right? How much distance you travel from here to here, which is 0.6 meter. During that time, how long did it take? 0.2 seconds, right? This is meter. So this is 3 meter per second is your velocity, right? The wave velocity. Okay, we have a very short lecture today, but you learned really extremely important in the formula, right? That merge everything you have learned so far, right? Which is what? Your position, vertical position graph as a function of time is the combination A times a cosine 2 pi over lambda times x. And then if it's moving to the right, then that's a minus. If it's moving to the left, then it's plus. So you have basically plus minus 2 pi time period t times t. Again, in order to know this function, you need to know a lambda and period t. And then if you know a specific x or t value at each location or at different time, it collapses to what? Either history graph or snapshots. And then if you know both of them, you can find the height of it. And thank you. And then let me know if you have any question about the lectures today.